And this, ladies and gentlemen, is where we left off. Now, I've made a very crude drawing for you of what this yo-yo looks like. We're actually going to do both sides of the yo-yo, but instead of having to work both sides, I'm just going to find one side, assume it's symmetry, and then we'll multiply our answer by 2. So imagine if it's a sphere of radius 3, it actually would have come all the way out here, but you see it's only a width of 4, so we had a slice taken off the end. And then remember that here in the middle we took out that 1/4 inch slice, which it says right here, see, with a slit 1/4 centimeter in the middle, which means that on each side of the y-axis it's a 1/8 slit. Now I don't know if I'm going to get this drawing to disappear or not. I don't think I will, so I may have to stop the video at some point and take it off. So here's our formula for surface area. Now if you're wondering about all this in here, let me just show you some things that I've done here. We took, again, this function here, took its derivative. Well, this is, of course, 9 minus x squared to the 1/2. So I take the 1/2 out front, 9 minus x squared to the negative 1/2, and then by the chain rule, remember, I need the derivative of the inside, negative 2x. Well, half of the negative 2 is negative 1. And then I have x, so negative x over the square root of 9 minus x squared. Now, that's the derivative. Remember, you take the derivative and you square it. So negative x squared is x squared. And then this squared just gets rid of the radical, 9 minus x squared, and then 1 plus. And then as we mentioned, as for this problem, the radius of what we're revolving, which would go from here up to here, you see is just the height of the function, radical 9 minus x squared. Alright, so continuing on, we'll get rid of all this. And yeah, you see that's not going to erase, so at some point I'll have to stop the video to get rid of it. Continuing on, we do see that the 9 minus x squareds are matching up here, but I can't do anything with it yet because of the 1. Let me encourage you, just go ahead right now and take your calculator and come up with this answer. I am going to work it out by hand, but we'll get the same answer in the end. So what I did here was I got a common denominator of 9 minus x squared, which 1 becomes 9 minus x squared over 9 minus x squared. When I combine that to the top, the minus x squared and the x squared cancel, but the 9 is left over. Now the 9 minus x squareds will cancel. Square root of 9 is 3. You move the screen here so you can see everything on the bottom, which I didn't move the screen, I just clicked. I'm just doing all sorts of things wrong here, aren't I? There we go. Now the antiderivative of 3 is 3x, and there's my 2 pi still out front. Plug in my 2, plug in my 1/8, and in the end I end up with 45 pi over 4. But remember, that's only half of the object. That's just this first half. Multiply it by 2, you get 45 pi over 2, which does come out to be 70.686 centimeters squared. Hopefully you can see that well enough without me taking that shape off. Now, again, we went kind of fast through surface area, and certainly I'll answer any and all questions that you have. You won't have any problems like this in your homework. I just wanted you to see another application of the integral. There's your homework. Not too much for today, ladies and gentlemen. As always, work through what you can. Bring lots of questions to class tomorrow. And we'll move the screen up here so we can see, and then we'll stop.